Okay. So is this good?
Yes.
Yeah.
Yes.
Yeah. Hello, everyone. I'm Daniel Acun. I'm associate professor in computer science from CU Boulder. I must also disclaim that I'm the founder of Your Zero AI, and some of the stuff that I will present is related to that. So take what I say with a grain of salt. I don't know if you saw over the last couple of weeks, there were a set of papers that came out in Nature. And I was small part. I play a small part in that set, where the Center for Open Science, led by Brian Nosek, did two things, or many things, but one of the two things they did, they tried to reproduce papers from social and behavioral science, and also replicate. So I don't know if maybe this is the right audience, but there are like differences between replication and reproduction. So reproduction, you take the same data, the code, and you try to run it on your own space. And replication, you don't. You take the claim from a paper, and then you try to do everything yourself. You get the subject. So this is from social science. So let's say if it's a claim about whether wine reduces or improve aging or something like that. So you get the subjects to make them drink wine, which sounds lovely, and then you measure if that actually impacts aging. So to sum up this huge effort that involves many labs across the world, the reproduction and reproducibility was around 50%. So 50% of the claims, and these were claims that were relatively prominent, that people thought were real. People like this even appear in like popular media, like the wine example, although they didn't run that, but something like that, where you will see it appear in kind of New York Times. And so these are like claims that people have been talking about for a long time, and you would think that they will reproduce or replicate more, but only 50%, a little over 50% reproduce. So this is before AI, and before, in the sense of before AI entering the process of actually creating new science. So what I've been working on in my lab is to kind of think about what will happen, or what is already happening with AI entering science, finding research, helping with ideation, with coding, with analysis, writing papers, the entire pipeline. So that's going to explode the number of claims, of course, but are we ready to also increase the amount of things that we can verify? So the production will increase, that's a central issue, but are we ready to increase also the verification side? And I use verification, so I don't use reproducibility, replicability. I think there are other things around these issues. Okay, well, so I will talk about something more theoretical, in the sense that we've been thinking about this for relatively simplistic models of what will be the rate of increase of claims versus the rate of increase of verification. And we'll start with a paper. I'm not sure how many of you know this paper. You need this paper from 2005, sorry.
Yeah.
Yeah. So this is the most cited paper in that journal, PLOS Medicine, which is a pretty good journal. And the title of the journal is the title of the paper is a little crazy. It says why most published research findings are false, and this is related to reproducibility. So basically, this paper is in a sense saying we should expect things to not be replicable or reproducible. That's just how science works.
Right.
And actually, the argument is relatively simple. You will think that it will be like an incredible math paper or like data paper, but it's actually just a Bayesian argument. The basic ingredient is that scientists are going to study things that are likely not true, because you want to study something or publish in something that will be surprising, and therefore it will be published in a good venue. So you usually study things that are like obscure or like interesting. So that reduces immediately kind of the prior probability of something being true. So if you just take the basic argument of saying how science works, how you do a statistical test, the bias that you have, so you like kind of what Jay was saying, you try different things, there is this path of things that you try, and then you publish only the thing that you find, so it's like you're biasing your results. And on top of that, you have many labs trying the same things. then that just increases the probability of something not being true. So as an example, you see like a little play with numbers there. If you take like a typical research paper with a little bit of bias, and you will get, instead of being the probability of something being true more than 50%, which is something that you would expect, in this case it's just 8%. That's in medicine, that's called PPV. So kind of just to link it to what I was saying before, you see a paper that claims that wine reduces aging by 1 year, but the probability of that being true, this is saying, is 8%. Okay, then we did a follow-up. Well, the previous wasn't a paper of mine, but we did a paper with a student of mine that came out a couple of years ago, where we said, well, if something is not true, that doesn't mean that it's necessarily bad, because it depends on what you're studying. If you're studying cancer and people are desperate to find solutions to that disease, that terrible disease, well, it might be good to just try something, even though if it might not be true. So what we found is that there is a gradient. So if you're studying something like lung cancer, it turns out that there is not a lot of research, but the benefit of finding a potential solution, even if it's just basically we're gambling here. We just want to try something. So we can afford our results to be less true, because lung cancer, if we discover a cure or improvement, it will just have such a huge impact in society. Whereas something like colon cancer or brain cancer, the kinds of research that we need there are more incremental. We know a lot about them, so we need to maybe not gamble so much. We need to be very careful about what we do. So lately, I've been thinking about what will happen with AI. And this, I won't go into the details, but basically, I'm trying to think about how AI is going to make this even worse. Because basically, in the sense that we'll have so many more claims that are going to be hard to verify. Basically, the cost of generating claims, of doing the experiments with AI, and I'm talking about perhaps more of the data analysis kind of experiment, is going to be reduced so much that we're going to have many, many papers. And since related to the company that I run, I work with publishers, and they're seeing 40% plus of papers that they receive are completely AI generated. So they've seen an explosion of AI generated papers. Lots of claims, but how do we verify them? So we run this little model of the cost of claims decreasing because of AI, but the verification cost kind of not keeping pace with that. And what we see is something that perhaps it's a little obvious, is that we see a huge increase in claims as AI capability increases, but the ability to verify those claims is not increasing as much. So there is a gap there in that space, in that divergence. So possible solutions for this, and we've been thinking about this, and talking of funding, we're also looking for funding to explore some of these solutions. One is something that people have already explored, which is, well, if you publish a paper, everything that is part of that paper, the data, the claims, everything, the code, should be machine readable, so that machines could easily verify that. So it would decrease the cost of verification. That would be one solution. And that will be the largest improvement in this discrepancy. The second is something called pre-registration. I'm not sure how many you are familiar, because that's more in social sciences. So there is a huge bias. Everybody wants to show that wine decreases aging, because all of us want to drink wine. So pre-registration is like you register first what your hypothesis is before carrying out the study, and that should decrease the bias, because you will only publish if you agree with that registration. You kind of pre-register everything that you will do, so that you don't get into this forking path of possibilities and increase your bias. The third solution is what we have been exploring recently, and is to decrease the cost of verifying the claims in a paper. And we are approaching that with AI-assisted peer review. So that decreases the validation cost, and that also might increase the accuracy. I was very skeptical of all this. I thought that AI reviewers were not that great because I put my papers on ChatGPT, but we found that they actually can be really good if you fine tune them and if you do stuff that we've been doing. So this is a series of papers that we've been working on in my lab, and from 2024 with Pao and Tao Yochitin. He's here. He's my PhD student. And if I say something wrong, it's my fault. It's not his fault. But basically, we have this series of papers trying to improve how well these LLMs can detect issues in a paper. Basically, what we find is that they're surprisingly good. So, so the graph here to the right, can I move things? Okay, great. So this graph is kind of how much of what a good review is are these LLMs covering, and first of all, just the vanilla LLMs, if you paste into ChatGPT, is usually covering more things that humans do on average. Okay, so if you've submitted a paper to Triple AI or anything recently, you'll see that you receive AI-generated reviews, and I don't know about you, but I feel like sometimes AI reviews tend to point things that the humans don't point out, and I usually receive human reviews, and they're not that great. So on average, AI reviews are a little bit better, but at the high end, they're not as good as humans. So the good human reviewers are much better than AI. But on average, this is the average. So on average, we're doing better. So we try multi-agent systems with multimodality. So they look at the figures, the citations, and external sources. Recently, we've started to play with reasoning models. So these are fine-tuned models to try to reproduce what the good human reviewers do. And we have been really surprised with the results. They're much better than the other AIs, and they tend to be much better than humans as well. So we are hopeful that this could be one possible way of increasing the reproducibility, of lowering the cost of verification, just catching up with what I think is just going to be the future. I don't think there is a way around this, for good or for bad, that AI is just going to be generating, to me, 99% of science in the next couple of, who knows, months, year. So yeah, and I want to thank my collaborators, and I'll finish here. Thank you.
Thank you. Thank you. Questions?
Yeah.
You said that 90% of the science will be graded by AI. I hope that's not true, but I hope there's still a place for humans. But I do believe that reviews will be increasingly generated by AI or AI assisted. You said that in your experience, the high end of human reviews are far better. Anything we can do to bring AI closer to that? Why is this gap, I guess?
I think AIs are really bad at assessing novelty. That's one of the big issues. So if you look at, we look at, Nature family papers, some of those journals, like the high-end journals, they open their reviews, and typically they're really good at pointing out the novelty. They're really good at looking at the context. These reviewers at the context of the review. I don't know why, but there's a much higher stakes in the review process there. They really pay attention and read the literature, and they recommend references that are good. So novelty, I think, is something that is really hard for AIs to assess. So I don't know if you had the experience. If you paste your paper into ChatGPT, it doesn't really.
Oh yeah, it tells me that is great.
It basically tells you back what you already said in the paper, which is really annoying. Yeah. The other is multimodality. So the humans are looking at the figures, are looking at citations. So they're looking at everything at once, and AIs are not that great at that thing yet. So I think those things would increase the thing a lot. The other is just the input. It's hard for LLMs. It's surprisingly hard for LLMs to read PDFs. Mm-hmm. So if we pass the paper, the code, and they can, if they are able to ingest everything that goes behind the paper, I think that's also going to improve.
Why is it hard to read a PDF?
Well, PDFs are, I don't know, it's just surprisingly hard to parse a PDF. So there are all these.
No, it's trivial to parse a PDF. That's why my question. So
it's not trivial if you have
it's completely trivial. So let me explain. My question made no sense. One of the things I had to do back when I was in industry ages ago was to generate PDFs of like medical intake. And in the process, I learned how PDFs actually work. And it's just a structured document format like a Word doc that is a public standard. And in the process of late, because people have mentioned this difficulty reading PDFs, I'm like, why are you having problems? It's a standard format. Just go read the spec and you can get to the right pieces. I found a tool on GitHub that allows you to navigate a paper by section and pull out exactly the text exactly. So there's no OCR issues or anything else like that. I mean, it's a very straightforward process. How was the difficulty of hearing?
Yeah, I think it's more. I there is
touch on that if you like. Because of the way LLMs work, they're using different ways of examining your tokens and comparing the tokens themselves. So like a standard paragraph versus a paragraph in PDF structure is going to show up differently. And so it's having a lot of trouble connecting the dots. You have to use a tool. So they can parse PDFs. You just have to tell it to use a tool to do so. Otherwise, it's trying to parse it as is, like through the binary format. And it does not do that well.
Also, PDF is like a visual thing. Like, okay, here.
It's actually not.
Well,
the thing is it's not structured explicitly. It's for prints, and it's not like HTML. But I do think like
it actually is though.
So it may be the case that when you generate via LaTeX, it is a well-known structure.
No, it is. It absolutely is.
But it's not in the general case.
It is in the general case. That's my point.
Yeah, but it is for print as this.
Now, if you have an old school PDF generated from scan of a paper, then you have just images. You don't have to have that. Those are a problem. But if you actually generated it from something that generates, I mean, the reason why it's so small is because it's a structured format. Parsing it, if you actually follow the format's structure, is trivial.
Yeah. All I can say there are like 3 companies that came out last year. They got funded for $50 million just to parse PDFs because it's such a big problem. And it's also the problem with tables that are inside the PDF and equations. So it's not just the text many times.
Okay. Maybe I'll just very quickly ask this question. This is more of a suggestion. So when you're looking at these formulas of, hey, is the publication possible to be replicated? Do you actually look into coming from a more systems and background, we have these badges in place and, do they actually correlate with the badging process or the artifact evaluation process that is happening? Have you thought about, okay, is the claim being artifact is available? Is that true even or not?
Yeah, I haven't explored that, but what I've heard from, I think like DOAJ was giving badges to journals because they were like, the code was available or something like they had like guidelines and they basically don't do that anymore because people are gaming the system basically. The badges are a way of giving prestige to the publications or to the journals, and they're just gaming the system and it's having not a great correlation.
So you think a more reliable data set is the social science publications because they are registering their studies and you exactly know whether that would actually be replicable or not. So you the hypothesis, the claim over there, but actually getting the claim from the or taking these arbitrary claims, which is, hey, my artifact is accessible, functional, reproducible, those are themselves not very well established.
Yeah, so like registration is you limit what you will test. So you can then publish a paper where you will say, actually we tested this, but then that didn't work and we tested that.
Uh-huh.
That kind of limits the bias that you get. You basically limit big hacking. That's the basic
Okay,
idea.
okay. Okay, I'll just stop over here.
Yeah.
There's a lot to discuss. Sorry, I took more time. So yes, let's move on. And yes,
I'm
Bo,
not sure who's next. Yeah,
you are next. And
Sure.
thank you. Let's thank Daniel first. And,